we're going to count how many ways of choosing k out of n objects in two different situations. One where the order matters, and then where the order doesn't matter. So in this example, we're going to choose 3 out of 7 objects where the order matters. So for instance, we can use the set that contains 7 objects, A through G. So what we have to do is first figure out how many possibilities there are to put in the first position. There are 7 objects in the set, so you have 7 choices here. So now let's say that you've chosen one. Maybe we chose the letter D. And now when we look to see how many choices do we have in the next position, there are only 6 things left to choose from. So we put a 6 there. Maybe we chose the B. Now finally there are 5 things left to choose from. And according to the fundamental counting principle, you multiply those numbers together. And so that's going to give us the total number of ways of selecting 3 out of 7 objects where the order matters. So in this case we have 5 times 6 is 30, times 7 is 210. Now let's repeat the problem where we're choosing 3 out of 7, but in this case the order doesn't matter. Now we should note that in the previous example, all of these use the same letters, A, B, and D, but they're all in different orders. So in other words, each of these was counted once in the previous example. So that particular set of 3 was counted a total of 6 times. But in fact, every set of 3 was counted a total of 6 times. So everything was overcounted by a factor of 6. How do I know that they were all counted 6 times? Well, given 3 objects, how many different rearrangements are there? Well, there are 3 choices for the first, 2 choices for the second, 1 choice for the third. That's a total of 3 factorial, or 6. So we take our previous calculation, which was 7 times 6 times 5, and we divide by how many times does each set appear on the ordered list, and that was our 3 times 2 times 1, or 6. Now this could be simplified by doing the following thing. And so this could be represented in the following way. 7 factorial divided by 3 factorial times 4 factorial. And that gives us the formula for 7 choose 3. Or if we're just looking for a number, We observe that the denominator here is a 6. There's a 6 in the numerator. So this just looks like 7 times 5, which is 35.